In the summer of 1954, a small town southwest of Moscow became the setting for a new kind of historical boundary. The place was Obninsk. The machine was modest by later standards, a 5-megawatt electrical reactor built inside a Soviet research complex, feeding power into the grid on a scale that would not impress a modern utility planner. But the meaning of that connection was enormous. For the first time, nuclear fission was not only a weapon, a laboratory experiment, or a military secret. It was electricity entering ordinary wires. That is why the date matters, even though the surviving sources do not all phrase it in exactly the same way. IAEA material says that at 5:30 in the evening on June 26, 1954, the Obninsk plant was connected to the grid. Other historical descriptions use June 27 for the connection to the Moscow grid and the public milestone. The difference is a useful warning. History is often recorded through operating logs, official announcements, anniversaries, and later memory. The safe claim is not that one public anniversary erases the other. The safe claim is that in late June 1954, Obninsk became the first nuclear power station to send electricity onto a civilian grid. The road to that moment began in war. Nuclear fission had entered global politics through fear. The Manhattan Project, Hiroshima and Nagasaki, Soviet espionage and research, and the first Soviet atomic test in 1949. In the early Cold War, the atom was a symbol of destruction, secrecy, and state power. Governments did not merely study nuclear physics. They guarded it, funded it, and turned it into a measure of national survival. Any claim that atomic energy would serve homes, hospitals, factories, and city lights had to live beside the fact that the same science had already destroyed cities. Obninsk was therefore never just an engineering story. It was a political story about converting the atom from terror into usefulness, or at least presenting it that way. The Soviet Union wanted proof that it could match and surpass Western technology. It wanted a peaceful atomic achievement that could be shown to visitors, scientists, journalists, and allies. It also wanted practical experience with reactor materials, heat transfer, fuel behavior, shielding, operations, and the human discipline required to run a nuclear plant. Electricity was the visible product. Knowledge was another product. The reactor at Obninsk was called AM1, often translated as Atom Myrny, the peaceful atom. It was graphite-moderated, water-cooled, and used enriched uranium. Its 5 megawatts of electrical output were tiny compared with later nuclear stations, which would be measured in hundreds or thousands of megawatts. That small scale is part of the story. Obninsk was not the instant arrival of a mature nuclear industry. It was a bridge between research reactor, demonstration plant, propaganda symbol, and operating power station. Its value was not only how much electricity it made, but what engineers and states learned by making it. Inside such a plant, the basic chain of events sounds almost simple. Uranium nuclei split, the reaction releases heat. A coolant carries that heat away. Steam turns a turbine. The turbine turns a generator. The generator feeds electricity into a grid, but every word in that chain contains risk. The reaction must be controlled. Heat must be removed. Fuel must be handled. Radiation must be shielded. Instruments must be trusted. Workers must understand procedures not as paperwork, but as survival equipment. Obninsk opened a future in which electricity, bureaucracy, physics, and public trust became inseparable. The phrase peaceful atom was already becoming part of Cold War language. In December 1953, U.S. President Dwight Eisenhower gave his Atoms for Peace speech at the United Nations, arguing that nuclear knowledge should be redirected toward medicine, agriculture, power, and international control. The speech did not end nuclear rivalry. It sat inside nuclear rivalry. But it captured the new public bargain. Governments would ask citizens to see the atom not only as a bomb, but as a promise. Obninsk gave the Soviet Union a concrete answer to that promise. It said, in effect, the future is already connected to our grid. That claim traveled beyond one town. Visitors came, photographs circulated. Technical papers and official accounts turned the small station into a symbol of modernity. Later, Britain's Calder Hall would become a larger and more public commercial nuclear power milestone. The United States would connect Shippingport to the grid in 1957. Other countries watched, invested, argued, copied, and adapted. The nuclear age of electricity did not emerge from a single switch thrown in one room. It emerged from demonstrations, rivalries, national programs, and a belief that the energy inside matter could be turned into national development. The promise was powerful because the post-war world needed energy. Industrial recovery, urban growth, electrification, scientific prestige, and military competition all pushed governments toward bigger grids and new sources. Coal was dirty and labor-intensive. Oil was strategically valuable and geopolitically exposed. Hydroelectric power depended on geography and enormous construction projects. Nuclear power seemed to offer something almost miraculous: dense energy, modern engineering, and the possibility that a small amount of fuel could produce large quantities of electricity. That promise was never only technical, it was emotional. It told societies that the future could be mastered. But the risks were present from the beginning, even when public language softened them. Early nuclear workers operated in a world where experience was thin and secrecy was thick. Reactor physics was advanced, but operating a power station for years is different from designing one on paper. Materials swell, corrode, crack, and age. Instruments fail. Operators misread signals. Political pressure can reward success and hide weakness. Waste does not disappear because a speech calls the atom peaceful. Radiation cannot be negotiated with. The history of nuclear power is a history of astonishing engineering achievement and of repeated reminders that complex systems demand humility. Obninsk itself operated for decades and became part of a broader Soviet nuclear complex. The Soviet Union built larger reactors, exported technology, and made nuclear energy part of its image of scientific socialism. At the same time, the Soviet system's secrecy shaped what the public knew and when it knew it. That secrecy mattered later, most famously after the Chernobyl disaster in 1986. Chernobyl was not Obninsk, and it should not be used to flatten all reactor history into one warning. But it revealed how nuclear technology, institutional culture, design choices, emergency response, and political honesty can determine whether a technical accident becomes a public catastrophe. The wider nuclear story also includes achievements that are easy to overlook. Nuclear plants have produced enormous amounts of low-carbon electricity. They have powered cities, reduced reliance on fossil fuels in some countries, trained generations of engineers, and pushed international standards for safety, inspection, and emergency planning. They also left unresolved problems: high capital costs, long construction timelines, radioactive waste, weapons proliferation fears, security risks, public opposition, and the memory of accidents at 3 Mile Island, Chernobyl, and Fukushima. The point is not that the promise was false or that the fear was irrational. The point is that both were built into the technology from the start. That is why Obninsk feels newly relevant whenever the world rediscovers electricity scarcity. In the 21st century, climate pressure, grid reliability, industrial demand, and the energy appetite of data centers have pushed nuclear power back into headlines. Technology companies and governments talk about advanced reactors, small modular designs, plant restarts, direct power deals, and new finance. The language is modern, but the deeper questions are old. Who controls the technology? Who bears the risk? How much public trust is required? Can a complex machine be made reliable enough, affordable enough, transparent enough, and politically legitimate enough to solve the problem it is asked to solve? Obninsk does not answer those questions by itself. It gives them an origin point. It shows that civilian nuclear power was born not in a neutral laboratory outside history, but inside the Cold War, inside state ambition, inside the memory of atomic war, and inside a real need for electricity and expertise. Its small output makes the achievement more, not less, revealing. A 5-megawatt station could not transform the world's energy system overnight. But it could prove that a reactor could be coupled to a turbine and a grid. It could make the idea visible. There's also a human scale to the story that can be lost in the word nuclear. Engineers adjusted controls, operators watched gauges, physicists argued through calculations, workers moved through shielded rooms, pipes, valves, cables, and concrete. Local people lived near a facility whose meaning most of the world was still learning to describe. The first nuclear electricity was not a lightning bolt from the future. It was a workplace, a control room, a generator, a town, and a government announcement layered on top of years of research and risk. The mythology of nuclear power often swings between two extremes. In one version, the atom is salvation, clean, dense, rational, a triumph of science over scarcity. In the other, it is hubris, dangerous, secretive, expensive, and unforgiving. Obninsk stands before those arguments became familiar. It contains the seeds of both. It was a real technical milestone. It was also a state performance. It promised peaceful energy while living under the shadow of weapons. It opened a path to low-carbon electricity long before climate change became a central political issue. It also opened a path that demanded institutions capable of managing risk across generations. So the story of June 26th and 27th, 1954 is not only the story of who was first. Firsts are useful because they let us see a door opening. What matters is what was on the other side. Obninsk opened a door into a world where electricity could come from the heart of the atom, where national prestige could be wired into the grid, and where every kilowatt carried questions about safety, secrecy, cost, waste, and trust. The first nuclear power station did not settle the debate over nuclear energy. It began the civilian version of that debate. 70 years later, the question has not disappeared. When leaders and companies ask whether nuclear power can help run factories, cities, climate strategies, or artificial intelligence infrastructure, they are still walking through the door opened at Obninsk. The machines are different, the economics are different, the safety standards are different, the memory is heavier. But the basic bargain remains recognizable: accept a demanding technology, build institutions strong enough to govern it, and hope that the energy released from matter serves human life more than it endangers it. Obninsk was the moment that bargain first lit the grid.